Well, hello, and let's go ahead and continue with our learning about transcription and translation. So we are at translation. So remember, what's our goal? Our goal is to make a protein. How do we know how to make the protein? We need to put the amino acids together correctly. How do we know how to make the amino acids together correctly? We need to follow the directions. We need to follow the code given by mRNA. So we have thousands of different mRNAs, which make thousands of different proteins in our cells. And the ribosome is going to happily make the right sequence. It just needs to be given the right code. So here is our basic idea. So the basic idea, here's our ribosome in the blue, the big blue blob in the background, that's our ribosome. We have our mRNA strand in our kind of pinky orange down here. That's our mRNA strand. And the codons are every three letter of our DNA. And here we would have our tRNA molecules. And the tRNA molecules, remember, they have our anticodon that match the codon. And then we have the docking spaces for our correct spots. And so the basic idea is the right tRNA is going to float up, join with the right codon, and then we want to make a bond between our amino acid. Now, this is going to be a covalent, meaning it's going to be a good, strong bond that's sharing electrons. We call it a peptide bond because it's making a polypeptide. And so what you're seeing is tRNAs floating up with the right amino acid. Now, you guys just got done reviewing your slides. So the template strand was used to make the mRNA. The name of the enzyme is RNA polymerase. You would find ribosomal RNA in ribosomes. And then the anticodon matches to the codon. And then the other end of the tRNA carries a specific amino acid. And then this is our labeling. Here's our anticodon that matches to our codon. Here would be another anticodon, and you're going to get some practice. So here's the practice. Now, if this were a normal school year, I'd have all of these things on magnetic on our whiteboard, but here is a whiteboard. Here is our picture of our ribosome with our exit site, our peptide site, and our amino site. Now, notice I've lined up our mRNA strands so that the first three bases are in the P site. And that's where we're going to start. So we're going to create the first three amino acids in our ribosome. So let's take a look at this. Our first three nucleotides, which would be our first codon, AUG. Now we're going to drag they kind of look like monster Christmas trees to me, but we're going to drag our first tRNA and notice they base pair together. AUG matches with UAC. There's our anticodon on our tRNA, and it's going to bring the correct amino acid because they've already been linked together. Now we've got an empty area in our A site, so we're going to find the right codon. Let's see what the right codon looks like. Oh, we've got CCC, so we need to bring our GGG. That's our anticodon, and it's carrying our proline amino acid. Now, you don't ever have to write, you will always have that chart to know. But we know that it works because they fit. We have a codon CCC with our anticodon GGG. Now, what the ribosome is going to do is it's going to take and make a covalent bond between these two. There we go. Yay! Although mine, let's drag them together a little bit. There we go. And so we have now connected our amino acids together. Yay! Now, once we've done that, we don't need our tRNA molecules anymore. So watch what happens. The ribosome slides down and we get a new codon in our A site. And if that happens, this now becomes the anchor point and we can lose that empty tRNA. Now, that's okay. We've made a bond between our methionine and our proline. We've made that connecting spot so we can lose our weird little Christmas tree tRNA there. So let's turn our attention. Let's see what we've got here. Now our new codon is, if I can read that, that is GAU. Now, GAU, I just happen to have a tRNA that matches with our GAU. And that GAU would be our codon. What's going to be our anticodon? Well, you guys can stop. Remember, the codon is GAU. So what would the anticodon be? You can hit pause. Okay, and of course, maybe you're looking at the tRNA, but if my codon is GAU, my anticodon should be CUA, and that should be aspartate. Now, I know that because I kind of set this up, but if you want to double check GAU, you can go back to GAU. There's our aspartate. Now, some of these are just old words like aspartate, asparagine. So, again, you don't need to memorize those. Those are just helpful, kind of, that's the chart. So here's how it works. It's going to match up, and we're going to make our peptide bond again. And I'm just going to scoot this guy over so it connects. Now, we've made our peptide bond, and so maybe you can connect, maybe you can start anticipating what's going to happen. The ribosome is going to move down, and I'm going to get the last codon in our A space. We can now get rid of that empty tRNA. He can go back. Now, these tRNA molecules, they can just go and get another amino acid. But notice we have now started stringing our amino acids together. We've made our covalent bonds. Let's do one last one. Now, I ran out of my demented Christmas tree, so I just made a triangle shape. But I think you get the idea. Here we have CGA. If that is our codon, what would be the anticodon? CGA is the codon. Go ahead and you can hit pause. So if CGA is our codon, our anticodon should be GCU. And that should be asparagine. And I should have made myself another covalent bond. Let me just do that real quickly. And there we have our 4 connected together. And you can almost by now hopefully tell me what's going to happen next. Our ribosome ratchets down, and you would keep going. This tRNA would be gone, and you'd have a new tRNA that comes into play. So that should be super, super helpful for you to kind of practice what is happening. So you're going to watch a couple of video clips that should help you understand what happens. And then you're going to kind of practice all of this in our slide 26, and then with a Jamboard.